Hello, everyone. My name is Jerome Singh, and I'm the Director of the Scientific Advisory Group on Emergencies, also known as SAGE. SAGE operates under the auspices of the Academy of Science of South Africa, which is a statutory body established by Parliament to serve as South Africa's apex science advisory body. Today's webinar is going to focus on the important topic of climate change. And in particular, we're going to be looking at climate change in relation to sub-Saharan Africa. There's growing scientific evidence, as we know, that the Earth is warming at an unprecedented rate due to human activities. And this is, of course, mainly due to the emission of greenhouse gases and also land use changes. Heat waves constitute a major threat to human health and, of course, the ecosystem as well. Heat wave exposure has disproportionately increased in the lowest income regions globally and compared with the highest income regions over the past 4 decades. The poorest parts of the world are likely to be 2 to 5 times more likely to be exposed to heat waves than richer countries by the 2060s. And by the end of the century, the lowest income quarter of the global population, heat exposure will almost match that of the entire rest of the world. Now, with the support of the South African Department of Science and Innovation and the Academy of Science of South Africa, SAGE is hosting a 2-part webinar series on climate change and its anticipated impact on human health. This webinar series is co-chaired by myself and Dr. Cara D. Wright, who serves as a Chief Specialist Scientist at the South African Medical Research Council, and she leads its Climate and Health Research Program. To kick off this 2-part webinar series, SAGE is proud to host 2 eminent scientists. I will start off by introducing my co-chair and this webinar's first speaker. Dr. Cara D. Wright is a Chief Specialist Scientist at the South African Medical Research Council and leads its Climate and Health Research Program. She's also a research professor at the University of Johannesburg and an adjunct lecturer at the University of Pretoria. She researches environmental health in Africa with a focus on understanding climate change and air pollution on human health and well-being impacts to inform interventions and policy development. Her research fields also include solar ultraviolet radiation, dosimetry, and skin cancer prevention. Cara D. Wright is very, very accomplished. She has published more than 140 research articles in peer-reviewed accredited journals, and also she, in addition to having a very, very good publication record, is a committee member, or was a committee member of the World Health Organization Air Quality Guidelines Committee. She's also served on an intergovernmental panel on climate change assessment report 6. That was the chapter that focused on Africa. She was an author on that. She was a chapter lead author on the United Nations Environmental Program, Stockholm Environmental Institute's Africa Assessment on Climate Change and Human Health, and also serves as an author of a recently published United Nations Environmental Program report, in fact, a few reports. Dr. Wright is currently a council member of the American Society of Photobiology. She's a technical advisor to the World Health Organization on air quality, the International Livestock Research Institute, One Health, the Health Effects Institute on Global Health, and also a review lead for the National Institutes of Health and Nature collection on data science for health in Africa. And that focuses specifically on environmental health and climate change. So as you can see, Cara D is really accomplished and is an excellent speaker for our webinar series on climate change. Our second speaker for the first webinar is Professor Rajan Naidu. Rajan Naidu is a full professor and the head of department in occupational and environmental health at the University of KwaZulu-Natal. He's been active in academic research for approximately 25 years. His areas of research focus include occupational and environmental respiratory diseases, and more recently on weather-related health effects, with projects funded by several major national and international agencies, including the South African National Research Foundation, the US National Institutes of Health, and the European Union. He has over 120 peer-reviewed publications with presentations at several international conferences. He is an associate editor of the International Archives of Occupational and Environmental Health and the Journal of Occupational Medicine and Toxicology. And he also serves on the editorial board of the American Journal of Industrial Medicine and Environmental Epidemiology. He received his postgraduate training in occupational medicine at the University of Cape Town and his doctorate at the University of Michigan. He is currently the principal investigator on the mother and child in the environment, also known as MACE, or MACE, birth cohort, focusing on the impacts of ambient and indoor air pollution on the respiratory health of children. He has previously been the principal investigator on several large air pollution and respiratory health studies in South and Southern Africa, and that was funded by several international and national agencies. With those introductions out the way, I'm very happy to hand you over to Dr. Carity Wright. Her presentation will then be followed by Prof. Rajan Naidu's presentation. So over to you, Carity. Thank you.
Hello, I'm Carity Wright from the South African Medical Research Council, and today I'm going to speak about Africa and climate change, drawing on the crucial facts and figures from the IPCC 6th Assessment Report, specifically the Africa chapter, looking at impacts, adaptation, and vulnerability. First of all, let's look at what some of these terms mean. The IPCC is the Intergovernmental Panel on Climate Change. This is a large body which draws together the latest scientific evidence of the time around climate change and the impacts that it's having on Earth. Here they were working towards the 6th assessment report, and there were 3 working groups. The first working group focused on the physical science basis. The second working group looked at impacts, adaptation, and vulnerability. And the third working group looked at the mitigation of climate change. There were more than 200 authors in each of these working groups, and together these authors also worked to pull together the synthesis report, which was published in September 2022. More information is available at the website. I'm going to focus on Working Group 2, and this report assessed the impacts of climate change starting from a worldwide view to a more regional view of ecosystems and biodiversity, and reviewed the implications for humans and their diverse societies, cultures, and settlements. The report considers the vulnerabilities and capacities, as well as limits of the natural world and of human societies to adapt to climate change. This report also informs adaptation and mitigation efforts to reduce climate-associated risks, together with options for creating a sustainable, resilient, and equitable future. A full outline for Working Group 2's reports is provided on the right-hand side of the slide. It's important that I disclose that none of the figures that I'm going to show today are mine. They're all extracted from Chapter 9, the IPCC Working Group 2 6th Assessment Report, and this was as of the 24th of April 2022. For the very first time, the Africa chapter, illustrated on the right-hand side of the slide, has a burning embers diagram. This is a well-known IPCC diagram that is used to illustrate the relationship between global mean temperature increase above pre-industrial times in relation to impacts from or risks from climate change. There are 3 embers. The first is the biodiversity loss and ecosystem disruption ember. The middle ember is mortality and morbidity from heat and infectious disease. And the far right ember is reduced food production from crops, fisheries, and livestock. If we take the middle ember as an illustrative example, the red line is showing us recent climate change increase in temperature, just over 1 degree Celsius between 2010 and 2020. At around the 1 degree mark, we had medium confidence, illustrated by the 2 black dots, and we saw that there was a moderate level of additional impact or risk of risks due to climate change for these health outcomes. But as the temperature warms, so if we reach 1.5 degrees global mean temperature increase above pre-industrial, our confidence levels increase in saying that the level of additional impact or risk due to climate change is high, the purple shaded area on the graph. And these are excellent illustrations to show that if we are left to leave the climate to increase in terms of global warming, or leave it unchecked, or keep along as business as usual, the impacts for all three of these elements are likely to worsen. This slide illustrates climatic impact drivers in relation to the regions of Africa, as illustrated in the plot on the top left-hand corner of the slide. We're looking at a summary of confidence in the direction of projected change in climatic impact drivers across the African regions. Climatic impact drivers are drivers of impacts that are of climatic origin that affect an element of society or ecosystems. So these include extreme heat, cold spells, frost, landslides, snow, glacier and sea sheets, air pollution, and so on. And if we have a look at the example for East Southern Africa, where I live in South Africa, in Gauteng, for example, we can see that the very first column, which is mean air temperature, is red. We have high confidence that there is an increase occurring in this region for mean air temperature, and that is true for all regions across Africa. The same for the second column, which is extreme heat. The dot indicates to us that this has already emerged in the historical period from observed data. And when we see a dot, which is purple, then we know that this is likely to emerge by 2050 in various scenarios. And then the final dot is for emerging after 2050 and by 2100 in certain scenarios. The little notes, numbers 1 to 5, give us some additional data. And the blocks where it is white is where we have low confidence in the direction of change. In other words, the data were very mixed in the findings, and it was difficult to pull together a specific driven change based on the evidence that we have at this point in time. When we focus in on some of the more specifics of the impacts of climate drivers on human health, well-being, and livelihoods, one of the ones we can look at is the loss of biodiversity, which has a particular impact on food security for many nations across the African continent. The loss of African biodiversity under future climate change is projected to be widespread and increasing substantially with every 0.5 degrees Celsius above the current 2001 to 2010 level of global warming, and we have high confidence that this is the case. These plots illustrate to us the percentage species locally extinct in relation to temperature changes or increases by 0.5 degree increments over the course of the future. An important aspect of climate change, in addition to global warming, is that of extreme weather events. This includes droughts, floods, and other impacts such as cut-off lows. These series of maps illustrate to us the total numbers of people affected by these various climatic impacts across the African continent. Not only the total number of people affected, but in some instances on the far right, we have some information, although it's rather sparse, that in relation to the total number of deaths. And these are all highly likely to be underestimations. So there's no level of confidence assigned to these plots or these data. The illustrations of the pictures on the left-hand side are the recent flooding in KwaZulu-Natal province in South Africa. And while there's some debate about whether this flooding was related to a climate change event, it certainly does give a good example of what the dire consequences are of extreme climate event impacts. and we are likely to see more of these in the coming future. Drawing together the information that we could, we tried to put a list of risks for 8 health outcomes in relation to observed climate impacts and projected climate change impacts across the African regions. So the 8 health outcomes were malaria, dengue and Zika, cholera, diarrheal disease, HIV, heat-related illness, all-cause mortality attributed to non-optimal temperatures, which would be hot and cold, and air pollution-related health outcomes. So the increased global warming levels are shown relative to pre-industrial times, and we reviewed 58 observed impact studies and 29 projected risk studies. Just to note that when we refer to air pollution here, we were only considering particulate matter, which would include PM2.5 and PM10. So what's being illustrated is whether there have been observed impacts, first of all, in the malaria block highlighted in red, one can see that, and underneath that are the projected impacts at various global warming levels. The colors illustrate the possible number of people likely to be exposed. So at the bottom of this slide, you'll see the purple through to the green, and this gives us an idea of the number of people exposed, the number of cases, and the number of deaths, and so on. The dots infer the level of confidence. More dots means higher confidence. The evidence level is denoted by the letters R, M, or L, and then the African regions are listed too. Yellow suggested there was conflicting results. If you recall from the previous slide where we spoke about air pollution and hail, for example, having a low level of confidence, it was because there's a low level of evidence that's speaking in the same direction. So there's ambivalent evidence, making it difficult to draw conclusions. Having looked at the risk to human health, it's important to also think about well-being. An important part of well-being is a person's culture and heritage, and climate change is likely to pose a risk to Africa's cultural and natural heritage. These plots illustrate a number of important sites across the African continent, sites which are likely to be exposed to sea level rise and face medium and high risk of erosion, for example. These sites may be places where people practice traditional behaviors or practices, and in the event that these sites are no longer available, an important part of a community's heritage may end up falling away. An example might be in Limpopo, there is a waterfall site which is being used for baptism, and it's been used for that for many, many years. But due to a pressing challenge with drought and drying, then the amount of water in that waterfall and stream has decreased substantially over the years, that baptism process is no longer able to take place in the original site where it was planned to be done. So as part of Working Group 2's report, the Africa chapter tried to consider adaptation options using a very multidisciplinary intersectoral approach. So looking at these options across multiple sectors and ensuring that they could have potential for reducing risk across multiple health outcomes. So by considering their potential, the options' potential to reduce vulnerability, as well as potential barriers to implementation, such as social acceptance, one could then rate with a level of confidence how well this particular adaptation option might work to serve the purpose of reducing risks to health outcomes and try and create health benefits. So for example, in the third row down, the health system and primary health care services, the strengthening of these would go a long way to support all of those health outcomes listed at the top of the table. And the blue gradation colors say to us the potential for risk reduction, and our confidence around that is high if we were to improve health systems and primary healthcare services. And what the goal here is to really ensure that all sectors work together to try and bring about good health and well-being, access to health care in a way that can be sustained in a changing climate. Finally, there is some evidence to suggest that while we have the information regarding the science of climate change, the risks that are posed by the climate impact drivers, and the likely impacts that will be experienced and are being experienced around the world, it's more likely that people will act and behave differently when their experience and perception of climate change or a related climate event has been disrupted. So an experience and perception of change, that something is different. This may be, unfortunately, the experience of heavy flooding or living through a period of drought and having to make adaptation solutions in terms of water access. But only when people have had these experiences is their perception of change then affected by the knowledge that there is a potential risk, and the sense of urgency to deal with that risk goes up. So when that happens on the one side of the plot or the chart, if we look at the other side, it's really important that we still focus on providing climate literacy through curriculum, both at school and at university, as well as for professional training and for the broader community and public at large. Climate services still need to provide information that can help inform a person's response of what they're going to do when they face risk and sense the urgency to do something about it. And together, when we bring these together, we hope for a more transformative climate response with improved adaptive capacity. Finally, I'd like to acknowledge Danny Miller for support with concepts and writing through the Africa chapter, as well as the IPCC for the opportunity to be an author. Thank you.
Good day, colleagues, policymakers, and fellow scientists. I'd like to thank the Scientific Advisory Group on Emergencies of the Academy of Sciences of South Africa for providing me with an opportunity of doing this talk. I am Rajan Naidu, Professor and Head of Department of the Discipline of Occupational and Environmental Health at the University of KwaZulu-Natal. SAGE has kindly asked me to present on a very important and critical topic of our times on heat and its impact on health. Within this broad ambit, I've chosen to focus my talk on what I label as the silent disablers or killers in the climate context. I trust that you can see my screen, and I will proceed with my talk. So already in 2009, the Lancet Commission on Climate Change had declared that climate change was the greatest global health threat of the 21st century. Unfortunately, over the period that has since passed, we have made little inroads in addressing these challenges effectively, particularly in countries and in communities where this has the greatest impact. The Lancet Commission put out a complex pathway through which climate change has an impact on health. Well established and well known to all of us, greenhouse gases, which is the largest contributor to climate change, has an impact on the acidification of the oceans, as well as the direct impacts on altered rainfall patterns, rising sea levels, and extreme weather events. These then give rise to events such as flooding, heat waves, droughts, and fires, and resulting ultimately in a range of health outcomes, including malnutrition and undernutrition, impacts on psychological health, cardiovascular disease, respiratory disease, as well as infectious disease. But today, we're focusing on direct impacts of heat and health. Firstly, the impact of heat on Africa. While policymakers debate about the 1.5 to 2 degree rise in temperature, the impacts on Africa are even greater. As this graphic shows, that over the last 40 years, some countries in Africa have already seen a gradual increase of 0.5 degrees per decade, with the majority of African countries experiencing a 0.25 degree increase. The Intergovernmental Panel on Climate Change, in its sixth report, provides some more concerning news for Africa. Independent of the scenario chosen, either a 1.5, 2, or 3 degree increase in temperature, Africa bears the brunt of the impact. So whether the global average is 1.5, 2, or 3, Africa will experience an even greater impact. For example, if we do achieve the 2 degree target, Africa would be at the impact of a 2.3 degree increase in temperature. Similarly, the number of hot days or extremely hot days in Africa increases across these different scenarios. So what then are the health effects of climate change? It's expected that we're going to see, that we have seen in 2019, additional 475 million heat wave events globally. Directly as a result of the increase in temperature, we've seen a 53.7% increase in mortality among people older than 65 years old, resulting in a total of over close to 300,000 deaths in 2018. If we look at the target of 2 degrees Celsius globally, this is going to result in approximately 6 million people being exposed to heat events. And of these, at least 1.5 million are going to be both exposed and vulnerable. So the effect on heat on health is complex, is challenging, but it's important to be able to break these down into smaller categories to better understand the impacts and how we can intervene. So if you consider that the impact can be either direct or indirect, by indirect, which I will not focus on this talk, largely because much work has been done and these are relatively well known. So the indirect are impacts such as flooding, droughts, which then subsequently result in lack of food, a lack of access to food sources, marginalized communities. These will then have an immediate effect in such as death or adverse health outcomes, or because children at a young age are malnourished, they then become increasingly at risk for adverse health outcomes as they grow. Turning our attention to the direct impacts, these can be both acute, such as that felt through heat strain, heat stroke, or death, and then it could be chronic. And it is around this area that I wish to focus my talk today. And the area that I want to focus on is understanding how the impact of heat can result in what I label as the silent disablers or the silent killers in our communities. And we take this from the lessons we've learned from occupational and environmental epidemiology. Despite knowing that silica exposure causes immense respiratory, adverse respiratory health in workers, for we've known this for over 150 years, but in the early part of 2000, we saw an epidemic emerge in small villages in Turkey. And we only realized this through the research and the surveillance work done in those communities. Similarly, until we saw the reports from the Global Burden of Disease and IPCC and the World Health Organization, we were unsure or uncertain about the real impacts of air pollution on the health of our communities. It's clear now that, for example, in 2019, we had 1.1 million deaths in Africa due to air pollution. But these are the well-established facts that we see. For some other conditions, such as the loss in IQ points seen in young children, these are less directly observable and therefore often falls under the radar. And its impacts are felt within communities and within countries in the subsequent years after these children grow up, do not achieve their academic potential, and do not achieve the productivity that would be expected for the development of countries. Similarly, within the scenario of heat, while it's obvious to all of us when we have the peak exposures and the heat waves, these have direct acute health effects on communities, on members within communities. These result in increased admissions to hospital and also subsequently developing into chronic adverse outcomes. What is less clear is that if communities are exposed to lower levels than as defined as an extreme event for a longer period of time, is it possible that their health is being slowly compromised, and this slow compromise then places them at increased risk for chronic health outcomes at a later stage, as we've seen with the impacts directly due to air pollution? Who then are the at-risk populations for exposure to heat? Clearly workers in the outdoors, but also workers working indoors in foundries, in mines, in warehouses with poor ventilation are at increased risk for these outcomes. We are also concerned about those exposed in communities, particularly pregnant females, the elderly, infants, and those with pre-existing medical conditions. The impact of heat on health is across multiple organ systems and multiple outcomes. In the study by Miao and colleagues reporting on young adults and observing the impacts of heat on their lung function as they grew. So the impact was seen across their entire young lifetime, but with a particularly striking effect seen in the younger ages, and this continued as they grew. What is important, as I indicated, that those with pre-existing medical conditions are at greater risk, and this was evidenced in this study, where those young adults with pre-existing lung conditions had a greater loss of lung function as compared to those without. But what's important, equally important to note, is that those without pre-existing conditions also experienced loss in lung function. We see similar pictures emerging with cardiovascular health, and this is making reference to acute myocardial infarctions, heart attacks, or chronic diseases such as heart failure. We see the effects particularly in North Africa, but in other countries in Southern Africa as well. It is the impacts on reproductive health and birth outcomes that are particularly concerning. Nyadanu and colleagues, looking at over 5 million Ghanaian births from 2012 to 2020 found that stillbirths were significantly associated with heat exposure. Not only did this heat effects occur at particular periods in pregnancy, for example, particularly in the 29th to 33rd week of pregnancy, it also depended on exposure at particular points. So in lag 0, in other words, exposure that was taking place currently had a lesser effect as compared to chronic heat exposure that was taking place up to 4 months before the duration of the pregnancy, commencement of the pregnancy. We saw similar effects on perinatal death in the South African data set, looking at the South African National Demographic Health Survey and comparing this with the El Nino phenomenon that we saw at various periods from the period 2000 to 2015, and using the Southern Oscillation Index, which is an indicator of severity of the El Nino phenomenon. We saw that there was a pattern that emerged between perinatal deaths and the severity of this Southern Oscillation Index. What was obvious was that while the rainfall patterns were changing over these periods, certain provinces had reduced rainfall as well as increased heat and dry seasons. What was clear was that for these provinces, such as Northwest and Northern Cape Province, the increased risk for perinatal death was quite substantial when the Southern Oscillation Index was at its worst. Our concerns with the impacts of heat during pregnancy and at the time of birth is particularly concerning because we know that if the child is born compromised, then this compromised outcome has an ongoing impact as the child grows. But in terms of in the context of heat, this child affected at birth is subsequently affected as they grow in the neonatal phases, toddler phases, as well as in young childhood. And at each point, their risk for adverse health outcomes increases. But our concerns with heat extends more than just heat itself. What we have been observing is that there are other factors which increase the risk in the context of heat. Factors such as air pollution, access to water, food security, as well as the marginalization of communities increase the risk for these communities to have more severe adverse outcomes. In the study by Chen and colleagues looking at the small for gestational age risk in pregnant females, found that at particular points in the pregnancy, the risk for small for gestational age increased with the interaction between heat and particulate matter. For example, in the early pregnancy, around the weeks 2 to 5, and then subsequently in the period 19 to 26 weeks, the risk for small for gestational age increased as a direct result of the interaction between heat and particulate matter. Turning our attention to kidney disease, a number of studies done over the last 10 to 12 years have shown an increased risk for either chronic kidney disease or reduced kidney function, done in a variety of different contexts. We have explored the impact on kidney function in sugarcane workers in Eswatini. We found that up to 14% of those workers had some level of kidney function compromise. Dehydration amongst these workers, in at least 40% had reached the level of severe dehydration. These impacts are not surprising given the number of hot days that these workers are exposed to. Using a standard of approximately 27 degrees Celsius, find that in the work that we've done, these workers are exposed to these high levels on most days of work. So given these wide-ranging impacts that we see, I believe that we face what I refer to as the epidemiological conundrum. We know the effect of heat on health of our communities. We know that this effect is most impactful in the marginalized and most vulnerable communities. On the other hand, we know our countries have focused on economic development. Unfortunately, there's a point at which economic development comes at a cost of addressing the health risks faced by these communities. So while economic development is important in addressing the specific social determinants of health, such as household income, access to services, access to healthcare, access to education, at the same time, these very same factors influence the risk that these communities face. So clearly, we need to focus our attentions on the interventions, allowing for adaptation of our communities to this increased risk. We need to consider heat action plans at a variety of levels, as well as review the resilience of our health systems to address these challenges. Heat action plans occur at a primary prevention level. In other words, we know people are exposed. We now need to figure out how do we reduce the hazard severity and limit the exposure. Secondary prevention, which focuses on knowing that disease is likely to occur, how do we prevent its occurrence? And then tertiary, knowing that disease has occurred, and how do we limit its progression or alleviate symptoms? Primary prevention is largely at the level of policy and legislation and enforcement. Particularly for workers, we need to make sure that we have new legislation that manage the heat exposure for workers. This includes establishment of new occupational exposure standards. We also need to consider how we develop policy for other controlled environments, such as those in school and other settings that communities may be exposed to. Heat action plans may take place at a number of levels. At a national level, we need to look at the implementation of warning systems and health surveillance programs. And at a local level, we need to consider programs such as education and awareness. We need to consider how we restructure workplaces and we restructure other environments through the introduction of cool zones and designated public cooling systems. We need to consider how we organize work. Should we be considering starting work at an earlier time and having longer breaks during the day? We also need to focus, given the importance on antenatal health, how we implement new and revised antenatal health services. The WHO has defined health systems resilience as the capacity to anticipate, respond, cope, recover, and adapt to climate-related shocks to bring about sustained improvements in population health despite the unstable climate. Now, this concept by the WHO can apply to any challenge that the health system may face. Replace climate-related shocks with global pandemic or outbreaks. And we see we need essentially a effectively functioning and responsive health system that incorporates strong leadership and governance, a workforce that is fully aware of the pending challenges, health information systems, services, products, and technologies that address the issues, as well as adequate financing. It is only through the implementation of these health systems that we will make sure that our communities, the marginalized, particularly protected against the onslaught of heat and climate change. I thank you for your time, for listening, and I trust that you found some value in the concepts that I put forward to you in addressing the silent killers in the context of climate change. I thank you for your time.
Thank you, Karadi and Rajan, for those excellent presentations. Karadi started off by providing an overview of crucial facts and figures from the International Panel on Climate Change, also known as the IPCC, and she focused particularly on Africa. She highlighted that if we adopt a business as usual approach and don't take any steps to reduce greenhouse gas emissions, there will be significant biodiversity loss and ecosystem disruption, increased morbidity and mortality from heat and infectious diseases, and reduced production from crops, fisheries, and livestock. Karadi also highlighted that climate change is likely to pose a risk to cultural and natural heritage, which will likely impact on people's well-being. She also highlighted that adaptation options across multiple sectors have the potential to reduce risks across multiple health outcomes. She concluded by emphasizing that we need to change perceptions and improve climate change literacy in schools, universities, and society at large. Prof. Rajan Naidu's presentation focused on heat and its impacts on health, with a particular focus on Africa again. He highlighted the direct effects of heat on health, with a particular focus on chronic health implications, which he terms silent disablers or killers. Prof. Naidu highlighted alarming scientific projections. For example, projections show that children born in 2020 under a 1.5 degree increase scenario will be exposed to 3 to 4 times more heat waves in their lifespan compared to people born in 1960. However, this is worse in some countries. For example, in Angola, people or children born in the year 2020 are 7 to 8 times more likely to experience heat waves in their lifespans compared to people born in 1960. He highlighted some of the groups and communities who are particularly vulnerable to heat waves, including both indoor and outdoor workers, as well as the elderly, the pregnant, infants, and those with pre-existing medical conditions. He highlighted that heat waves resulted in an almost 54% increase in mortality in people 65 and above in 2018. And this is quite alarming, as it equates to almost 300,000 additional deaths from heat waves in 2018. He also highlighted that 2019 alone resulted in a staggering 475 million heat wave events globally. Prof. Naidu highlighted that extreme heat impacts on multiple organ systems and multiple health outcomes, including respiratory health, cardiovascular health, reproductive health, stillbirth outcomes, maternal and child health, perinatal deaths, and kidney function. He highlighted that during a heat wave, if a child is born compromised, this compromised outcome has an ongoing impact as the child grows. In the context of a heat wave, the child is affected by heat during birth, in the neonatal phase, toddler phases, and the chances thereafter, if they've experienced heat waves in all these previous phases, the chance of experiencing adverse health outcomes in each stage of childhood is then thereafter affected. Prof. Naidu highlighted that marginalization increases the risk for affected communities to have more adverse health outcomes. He stressed the importance of heat action plans at the national and local level, and he urged a review of the resilience of our health systems in sub-Saharan Africa in relation to projected changes to local climate. He also proposed new legislation to govern heat exposure for workers, as well as new occupational exposure standards. He also stressed that we need new policies to govern teaching and learning in heatwave contexts. He concluded by strongly recommending the development of heat action plans, early warning systems, and awareness raising. I think in conclusion then, we can say that emerging scientific evidence highlights that people with lower incomes are exposed to heat waves for longer periods of time compared to their higher income counterparts due to a combination of location and their access to heat adaptations like air conditioning. Obviously, people in low income settings are not going to have access to air conditioning. So of course, they'll suffer more adverse health outcomes without those adaptation strategies. Managing the risks of heat waves will require investments to reduce exposure and sensitivity and to increase our adaptive capacity. Projected increases in heat wave frequency, duration, and severity speak to the urgent need to invest in prediction technologies to enhance our preparedness and to minimize adverse impacts. Moreover, mitigation and adaptation measures should be prioritized. For example, stakeholders should develop active outreach programs, exposure reduction measures and monitoring, and map at-risk groups. Moreover, health facilities should develop plans to increase their surge capacities during heat waves. The impacts on rural and metropolitan populations, as well as women, men, and children, need to be explored and understood separately so that local health systems can plan accordingly. Emergency heat management and heat action plans should be highly tailored to the highest risk groups in affected settings. For example, construction workers, agricultural workers, children, the elderly, and individuals with cardiovascular, respiratory, renal, neurological, mental, and behavioral disorders. Heat wave action plans should be tailored according to the population needs and their level of vulnerability. With these concluding remarks, I hereby close the first part of this webinar series. I thank you very much for your attendance and for your attention.